Well, good morning, everybody. Here we are on another glorious Friday. Aren't you excited? Today I wanted to talk some more about global climate change. I know I promised you a few weeks ago we'd look at it some more. Uh, this time I'm going to use some actual data that I've found, and I think we're going to be surprised at what we find about global climate change. Um, as our good old flat earthers want. Let's do it with a scientific method, okay? Uh, my observation that I've made is that global temperatures seem to be rising. My hypothesis is that there's a current serious global climate change caused by human activities. Uh, my background research, I looked at our previous video, Is Climate Change Real? And you can find it there on my channel if you want to look it up and look at it again. And my experiment, I'm going to look at various reports from many agencies to see uh, how they come up with actual climate change. Once again, I think you'll find it startling. The definition of climate: climate is the long-term average of weather. So you see the weatherman on TV, all of that stuff that they report that you see on TV, they also save that data, and there are all kinds of reports and studies that come out of that data over time. Uh, Here's my first uh, look at temperature data. Uh, so this is from, believe it or not, 550,000 years ago up to the present. So as you could expect, the graph is kind of squished. Each data point, it's what's called a moving average of 1,000 years. So as they move over a year, it's 1,000 years around that data point. They move over another year, 1,000 years around that data point. So it's moving as you move up. Each peak is a warming time. I called it a temperate age. I don't know what the real term is. Each valley down below is the following ice age. So there's a warm period and an ice age, a warm period, ice age for 500,000 years. Um, and um, the vertical axis is the change in time, in temperature, uh, not uh, it's not actual temperature, it's the change. Uh, so I tried to look at where the peaks were, and they're at about 2 degrees higher than average. And the low point, the ice age, is about -4 degrees, or 4 degrees below average. Uh, so uh, what I think you should gather from this is that there's a repeating series here, and that it's been pretty much level for 500,000 years. So we can see it as very level. Now, if we look at the sea, the ocean temperatures, here's a graph from 1880 through 2020. So they've done a little bit of forecasting here. But as you can see, clearly there's been a rise in sea temperatures. This rise in sea temperature, remember, it's very slow compared to air temperatures because the ocean is so vast and deep. Over to the left, you see a red arrow there. I put which stands for around mid to late 1800s. I just wanted that for a reference because I'm going to use that later on. Here are some recent temperatures. These are surface temperatures, so this is from 1870, again about where I was thinking as a reference, up to 2020. So you can see a very clear rise in temperature. I didn't have the actual data, so I can't tell you exactly what that line is, but there's a very clear rise in temperature there. This is temperature versus CO2 levels. You can remember this temperature graph from our previous slide, and it was showing temperatures, surface temperatures, and you can see there the rise in CO2 levels, which corresponds to the temperature rise. So speaking of CO2 levels, if we go back, say 3,000 years and look at the CO2 levels, you can see basically it was pretty much level. There wasn't hardly any change until about 1850, late 1800s, and then you can see it all of a sudden starts a steep rise, and that dark blue line there is like a jagged up and down changes. So definitely a rise in CO2 levels in the last few years. This is greenhouse gases, which again is also mostly CO2. You can see these are projections based on models that they've created. So they use this representative concentration pathway, and these are the different values that they use for their simulation. But you can see that they're expecting right now the CO2 levels around 350, and remember it's done a steep rise since 1870, and now it's they're expecting an even steeper rise up to 1250, which is just astronomical. Here we have ice melt, which is, again, if you look at those RCP values, those are the same as the previous slide. There's historical data, and then they have observed melt. What this is showing is the extent of the ice in millions of kilometers squared. So it's the area of ice, of ice. And the historic data, you know, it stays pretty level. You expect, you know, there to be some ice melt, and then it to go back to where it was. In the observed data from recent times, you can see that the ice is melting. There's a lot less than there was around the turn of the 20th century. And then the projected ice, you can see from the current data on into the future, it's just going to get worse. So if the ice is melting, the sea level must be rising, again, which you can see clearly. Started probably around 1870. There's my red arrow, that's the reference point. And although it doesn't show on here, but you can see it kind of levels off around 1870, 1850. But the sea levels now are seriously rising. They're in that little inset there on the left, definitely rising. The graph fit definitely shows some rising there in sea levels. Now, out of curiosity, I thought I would put all those graphs together in one slide so that we could see from that reference point where the graphs coincide. Actually, I used 2000 as the reference. So for the year 2000, and before that, it's been rising. So we have temperature rising, CO2 levels rising, surface of the sea temperatures rising, ice levels are decreasing, melting, and then down there at the bottom we have the sea level rise. So it seems to me, I think it's very clear that there is definitely a climate change going on, and so that's the part I think is rather startling. Here is the summary, conclusions, I guess, if you want to call it that, at the end of my scientific method. They're saying that solar magnetic activity is going to drop between 2030 and 2040, and which means in 15 years, Earth could sink into what researchers call a mini ice age. This prediction is known as the sun's 11-year heartbeat. The next geologic ice age, and you remember our first graph showing ice ages, is not due for 100,000 years, and yet we're seeing considerable climate change here. For the near future, we're going to have to expect some global temperature rises. Note in all of the previous graphs, this climate change is triggered by increased CO2 levels, which appears to have started in the mid to late 1800s. So I wonder what that could have been, mid to late 1800s. Anybody have an idea? I looked it up and noticed that the Industrial Revolution, which took place from the mid to late 1800s through the 1900s, this was a period during which predominantly agrarian rural societies in Europe and America became industrial and urban. The automobile, remember, was invented around 1900. So there's quite an unusual change going on that started with the Industrial Revolution. Oil usage, other fuels like that have increased CO2 levels. This is a sort of a chart of how climate change is making Americans sicker. This doesn't apply to the whole world, but you could imagine that it also occurs in Europe and Asia and Africa and South America. But I know it's hard to read those little symbols. At the right, we have extreme temperatures, outdoor air quality, extreme events like hurricanes and tornadoes and that kind of thing, food related, water related, mosquitoes and ticks, wildfires, and mental health and well-being. So all of this is increasing with the climate change, and we are becoming sicker as a result. My joke of the week: climate change is no joke. So we can remember that. See the clown there.